Welcome to the guide of mastering one of the machine learning's most fundamental concepts, the Bias-Variance Trade-off. Today we will explore this topic through a common interview questions. By end of this video, you will answer such question perfectly and efficiently. And not only that, but also understand this concept that separates beginners from the professional. Let's go dive. So imagine you are trying to hit the bull's eyes here, but you are keeping a mistake in the same direction every time. That's called a bias. In machine learning, bias is when your model is too simple and keep making the same mistakes. It's also using straight rules to measure a curved line, no matter how you try. It's just one will not, let's see, fit. High bias cause underfitting, where the model fails to capture the uh, let's see specific patterns in your data. Remember, bias is the being consistently wrong. So as you can see here, the bias is high, but most of the hits, let's see, are in the same direction. But here is scatters. Not only in one direction, but this is a high bias. And before uh, uh, going to dive into bias and bias, bias is related to training. I'm just trying to make it simple. Bias is related to training, and variance is related to validation or testing. And let's say you are training, your bias is high. It means the training data it's not, let's say, stable. So it's now underfitting. We will see the in with some examples and illustrations. And the next is what is the variance in machine learning? So now you are now picture throwing the dots at a board and they scatter all over the place. Let's see, right? And some near to the center and some are far away. So that is variance. In machine learning phase, in when your model is too sensitive to small changes in the training data, it's like a student who memorize exact answer for practical practice test, but can't handle slightly different questions on the real exam. If the teacher just changed the question slightly, he will not able to answer these questions. So high variance cause overfitting, where your model learn the noise instead of the signal. So remember that variance is about being inconsistently right. So as I mentioned in the beginning, the bias is related to the training, and the variance is related to the validation. So now, if the bias is high, it means that is overfitting. If the variance is high, it means it's no, sorry. If the bias is high, it means it's underfitting. If the variance is high, it's overfitting. So the variance, let's say you are training the model and it was working perfectly on the training part, but for the validation, the variance was high. It means the model is not able to work on this validation data, but it work well with the training data. So, so how do bias and variance contribute to overall, let's say, error? So think of a model error as a simple recipe. It's a total error. You can see the total error is bias square. This is the bias square plus variance plus irreducible error. The irreducible error is the like that the noise you can't eliminate. So you can see, for instance, the 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 irreducible error is, for instance, in this point. Even if you try to reduce these errors, you will not be able to, let's say, eliminate this. This is, for instance, this. So no matter how good your model is. So bias square represent how far your prediction are from the true values on the average. And variance show how much your prediction would change if you use different training data. I mean, training data, it means training, let's say a batch. And the magic happens when you find the perfect balance that minimizes the total error. It's like adjusting the temperature and time when back. So you get let's say both right, and you get perfect result. So let's just see this incredible, let's see, figure. So when you start the training, the error will be, let's see, so high, very high, and it will reduce by, let's see, by the time, if it's let's see, we are assuming that it's working in a good way, it will be reduced. And for the validation it will be the same, and every time it will be reduced until this point here. This is the optimal balance, and until this point here you can see the model is perfectly working. And for this black here, black curve here, it is the total error. So for instance, in the beginning, it is this one plus this one here. I mean, this is the total error. This is the curve of the total error. And what is the difference between high bias and high variance? So let's use the our let's see, pulse eye analogy again. A high bias model, it's like high bias. When you say, let's say you have a data, and this data has a different, let's say, distributions, and the model itself can capture the patterns, the hidden patterns from these data. So it will be now high bias. And the high variance, it's when you, let's say for instance, this is the high variance here. So when you see you have training your model, and the error in the training, it's really close to zero. But when you try to predict something, you have totally different, let's see, an unexpected result. So this called variance. And the idea is, let's say, to make it balance between this and this. We have already seen in the last video. So maybe the question is, what is the trade-off between bias and variance? So the bias and variance trade-off is like, give me 1 minute, please. Yeah. So the trade-off with bias and variance trade-off. So if you make your model more complex, it will the bias will be decreased. And if the variance, let's say, bias decreased, as model complexity increased, and variance increased as model complexity increase. So we have seen the previous slide. The optimal point is minimizing the total error. This one here. We need to minimize this total error here. Okay, so for underfitting, let's say high bias, both training and validation. Where is this? Yeah. For underfitting, high bias, let's see, both training and validation errors are high. It's like a student who fails both practice test and also the real test. For overfitting, let's see, high bias is training error is low, but the validation error is high. So it's like a student who ices, let's see, practice test, but fail in the real test. The solution for that, for underfitting, make your model smarter. For overfitting, simplify your model to get more data. So how can we detect the underfitting and overfitting? So detecting underfitting and overfitting is like being as a detective. So look at your learning curve. For instance, you have the learning. For instance, if you are by using PyTorch or Keras, or anything. So you will have a curve like this, and they tell you the whole story indeed. So for overfitting high bias, both training and validation errors are high. And for the overfitting, the training error is low, but the validation error is high. So the solution for that, for underfitting, make your model smarter, and for the overfitting, make your model, let's see, get more data. And you can see the solution for underfitting: increase the model complexity, add more data, reduce the regularization, and also feature engineering. So, for instance, select some let's say representative features. And for the overfitting, decrease the model complexity, add regularization. So you have to add penalty for the model, get more data, and for instance, early stop. If you already, let's see, reach this overfitting, you have to stop the model. Okay. So the last one, I think, the last one is how can we balance bias and variance in practice? So to balance bias and to balance bias and variance, you have several, let's see, tool in your, let's see, toolkit. So cross validation is getting multiple opinion before making a decision. So one is cross validation. So the second one, so for instance, here you can see cross validation, use cross validation to evaluate performance. And the second one is regularization. It's to add penalty to your model. It's L1 or L2. And this is to combine between L1 and L2 regularization. So I will let you know what is the difference between L1 and L2 and when to use this and this in the next video, maybe a couple more videos. And the third one or fourth one is uh, ensemble methods, combine multiple models. So you try to, like, for instance, random forest. How is working? It's trying to build different trees from different, let's say, subset of the data set. This will reduce the overfitting indeed. And also you can use a gradient boost, combine multiple models. So I have also, by the way, this explain this with real numerical examples. I'm quite sure that you will understand this if you go to this stuff. And also you have data. So more data, more training data, reduce variance, and also feature engineering, and also data augmentation. It's also for small data set. If you have a small data set and you would like to get a best model, you have to generate data, some images using data augmentation. And best practice, always use validation separated from the training. So when you try to build your model, try to split the in the beginning before the training, training, validation, and test. So this has to be separated from each other. This is you will understand. And oh, by the way, they all of this has to be in the same, let's see, the same distribution. And also monitoring the curve, the learning curve to detect bias and variance. And I think that's it for this. Hopefully this was clear and will help you in the for your interview. Thanks for watching and see you next time.